Here you can see a map of the island of Hawaii. This island is home to Mauna Loa and the other 4 volcanoes that make up the island of Hawaii. If you believe the world will end because of an asteroid, you might want to reconsider, because the end could come from directly beneath your feet. If you trace a line on a map from northern Nevada through southern Idaho and up into northwest Wyoming, you'll see an intermittent scar of volcanic mayhem that stretches 350 miles, 560 kilometers, and dates back 18 million years. Supervolcanoes are likely to have killed more people than asteroids, although it was previously believed that these massive volcanoes would take thousands of years to build and remain trapped beneath the Earth's crust for an equal number of years before having any impact on the globe. New evidence suggests otherwise. A new study suggests that these catastrophic eruptions, thousands of times more powerful than Mount St. Helens' 1980 eruption, might happen at any time. Is humanity on the verge of an apocalypse? Could a supervolcano be on the verge of erupting? Is it true what would bring about the end of humanity lurks just under our feet? Few things are as awe-inspiring as a volcanic eruption. They can't even be stopped or prevented. But what is a volcano and how does a volcano erupt? Let's dive into a bit of interesting geography. Many mountains form by folding, faulting, uplifting, and erosion of the Earth's crust. Volcanic terrain, however, is built by the slow accumulation of erupted lava. The vent may be visible as a small bowl-shaped depression at the summit of a cone or shield-shaped mountain. Through a series of cracks within and beneath the volcano, the vent connects to one or more linked storage areas of molten or partially molten rock or magma. This connection to fresh magma allows the volcano to erupt repeatedly in the same location. In this way, the volcano grows ever larger until it's no longer stable. Pieces of the volcano collapse as rock falls or as land slides. When molten rock below the surface of the Earth rises through volcanic vents, it is known as magma. However, after erupting from a volcano, it becomes lava. Magma is made of molten rock, crystals, and dissolved gas. Picture an unopened bottle of soda with grains of sand inside. The molten rock is made of the chemicals oxygen, silicon, aluminium, iron, magnesium, calcium, sodium, potassium, titanium, and manganese. After cooling, liquid magma may form crystals of various minerals until it becomes solid and forms igneous or magmatic rock. Originating at many tens of miles beneath the ground, magma is lighter than surrounding solid rock. It is driven towards Earth's surface by buoyancy. It is lighter than the surrounding rock and by pressure from gas within it. Magma forces its way upward and may ultimately break through weak areas in the Earth's crust. If so, an eruption begins. Magma can erupt in several ways. Sometimes molten rock pours from the vent as fluid lava flows. It can also shoot violently into the air as dense clouds of rock shards or tephra and gas. Larger fragments fall back around the vent, and tephra clouds may move down the volcano's slope under the force of gravity. Ash, tiny pieces of tephra the thickness of a strand of hair, may be carried by the wind only to fall to the ground many miles away. The smallest ash particles may be erupted miles into the sky and are carried many times worldwide by winds high in the atmosphere before they fall to the ground. So how many volcanoes are there? The U.S. Geological Survey (USGS) tracks over 160 active and potentially active volcanoes in the United States alone. There are about 1,350 potentially active volcanoes worldwide. About 500 of these have erupted in the past 100 years. Many of these are located around the Pacific Ocean in what is known as the Ring of Fire. However, there is a type of volcano not included in the numbers above. It's an underwater volcano. You may not know about these underwater volcanoes because they usually happen far away, but that does not make them any less dangerous. In fact, most volcanic activities happen beneath the ocean. 2/3 of all volcanic activity occurs in the deep sea. So how does an underwater volcano form? Actually, there is no difference in the formation of submarine or underwater and subaerial or on-land volcanoes. Underwater volcanoes also form when molten rock is produced in the second layer of the Earth's interior and makes its way through the crust. As Tamsin Mather, a volcanologist and professor of earth sciences at the University of Oxford, puts it, most submarine volcanism is associated with a continuously active volcanism along mid-ocean ridges, where two tectonic plates are pulling apart. The collision of two plates can also cause a volcano. If both the tectonic plates are beneath the ocean, then the volcano will develop underwater, said Hilo. Over time, they may grow to form volcanic islands, he added. Volcanic activity within a single tectonic plate can also result in the formation of a volcano. This can happen when a hotspot is underneath an oceanic plate, creating a chain of volcanic islands like Hawaii. One of the notable volcanic eruptions is the Hunga Tonga Hunga Ha'apai volcano in the Kingdom of Tonga. In addition to sending ash tens of thousands of kilometers into space, the volcano also caused a horrific tsunami that killed 5 people and sent shockwaves across the world twice. This is a taste of what's to come. Due to its high activity and proximity to human areas, Mauna Loa, the largest volcano, has been consistently monitored over the centuries. Mauna Loa has been erupting for 700,000 years. It is one of the world's most active volcanoes, with the first recorded eruption in 1843 and the most recent in 1984. In 1930, the U.S. Geological Survey published a geologic map of the Hawaiian Islands that shows the many layers left by the eruptions of both Mauna Loa and the adjacent Kilauea volcano. There are 5 above-ground volcanoes on the island of Hawaii, but Mauna Loa is the world's largest, accounting for more than half of the island's surface area. The volcano has a surface mass of 5,271 square kilometers, 2,035 square miles, and a maximum breadth of about 120 kilometers, 75 miles. The vast majority of the volcano's huge structure is submerged. At 56,000 feet, 17,170 meters tall, Mauna Loa is nearly twice the height of Mount Everest, as measured from the ocean floor's depressed crust to its highest point. Mauna Loa appears poised to erupt right in front of us, and its odds of erupting again are estimated to be about 100%, with possibly catastrophic consequences according to scientists. Let's go back to underwater volcanoes, because you are probably wondering what happens when a volcano erupts underwater. The impact of an underwater volcano eruption depends on its proximity to the water's surface. If the eruption happens at very great depths underwater, then the weight of the overlying water acts as a pressure cap. For example, if a piece of molten rock enters the sea 2 kilometers or 1.24 miles below the surface, it will come into contact with cold seawater and cool very quickly. The water will get very hot, but it won't turn into steam. The story is very different if the water is shallow enough. The magma starts to heat the water, which is then converted into steam, creating a big volume change. Steam explosions are really destructive because a small volume of water turns into a huge volume of steam. Aside from the risk of tsunamis, the massive ash ejected into the air when an underwater volcano erupts in shallow water can seriously impact people's health. The falling ash and emitted gases not only pollute the air, but can affect access to electricity and water supplies. Because they are underwater, submarine volcanoes are challenging to study. Due to their inherent inaccessibility, only a few active sites have been studied in detail. However, scientists working on land can learn about the history of a volcano by visiting the volcano sites and gathering data. This can be done using cliff sequences or digging holes and collecting materials. For underwater volcanoes, scientists usually have to rely on marine surveys and mapping technology like sonar. Even the threat of thermonuclear war or global warming would pale in comparison to an event like this, which would produce an ash cloud that would be capable of obscuring the sun. Millions of species would be wiped off over many years of freezing temperatures if this were to happen. While Mauna Loa is the world's largest active volcano, there are certain supervolcanoes that the world should hope to avoid. It turns out that the question with supervolcanoes isn't whether they could wipe out all life on the planet, it's a question of when it'll do it again. According to some scientific evidence, more than 95% of the world's plant and animal species may have been wiped out by an enormous supervolcano that erupted 250 million years ago. Yes, you heard that right. Around 200 million years ago, a supervolcano erupted with such force that it wiped out 75% of the planet's inhabitants. It was so massive that it split North America and Africa apart, forming the Atlantic Ocean in the process. The supervolcano Camp Central Atlantic Magmatic Province erupted over and over for 600,000 years. And there's bad news for those of us who live in areas where volcanoes aren't a problem. It wasn't that lava had covered everything in sight or that volcanic ash had rained down so heavily that everything was choked. Instead, it was the aftermath of the event's pollution. CO2 and carbon levels, for example, soared. The environment had been harmed. Only a few things managed to recover. It's worth noting that after the disaster, dinosaurs were able to evolve and take over before their own tragic end, demonstrating that no one wins for long. However, some rogue scientists believe that dinosaurs were wiped out 65 million years ago by a volcano, not an asteroid. There have been remarkable underwater volcanic eruptions, and we will dwell on their powerful impact next. Let's look at the most powerful underwater volcano ever recorded. In 2018, the largest active underwater eruption ever recorded birthed a giant skyscraper-sized underwater volcano. The insane thing about the eruption is that scientists are still making discoveries about it. What have they discovered? Scientists discovered the 2,690-foot or 820 meters tall volcano in the western Indian Ocean off Madagascar following a puzzling spate of earthquakes that struck near what is usually a seismically quiet area. After gathering geological data, including information from a 2019 underwater survey of the region, the team realized that there was a new submarine volcano about 1.5 times the height of New York's One World Trade Center. What's more, this new volcano draws from the deepest volcanic magma reservoir known to scientists. According to lead researcher Natalie Fouet, a marine geoscientist at the Paris Institute of Earth Physics (IPGP) at the University of Paris, the source of the magma, that is, the reservoir, is very deep, about 34 miles or 55 kilometers underground. It was the first time in volcanology that they could see such a deep reservoir at the base of the lithosphere, the outer shell of Earth that includes the upper mantle and crust. Between May 2018 and May 2021, more than 11,000 detectable earthquakes shook Mayotte, a small island and French territory between Madagascar and Mozambique. The most powerful earthquake was a magnitude 5.9, but there were also strange seismic hums or very low-frequency earthquakes that originated deep underground. They couldn't be felt at the surface, but they were picked up by seismometers around the world. These very low-frequency earthquakes are associated with volcanic activity. This sudden seismic activity was surprising, given that only 2 earthquakes have been detected near Mayotte since 1972, and until now, the most recent volcanic was left at least 4,000 years ago. In July 2018, scientists were stunned when they discovered that Mayotte was moving eastward at about 7.8 inches or 20 centimeters a year, as detected through GPS data. At that point in time, the island had only 3 or 4 GPS stations, so scientists installed global navigation satellite systems and ocean bottom seismometers around the island to learn more about the geological changes occurring there. The findings were extraordinary. The combined land and ocean bottom seismometers picked up 17,000 events between February and May 2019. In any serious discussion of underwater volcanoes, you will hear about Tamu Massif. This water is the size of New Mexico or the British Isles. Tamu Massif is located under the Pacific Ocean, about 1,000 miles or 1,600 kilometers east of Japan. Tamu Massif is the biggest volcano on the planet and also competes for the biggest in the entire solar system. It is in the same league as Olympus Mons on Mars, which had been considered to be the largest volcano in the solar system. There used to be misconceptions about Tamu Massif, as scientists thought it was a composite of smaller structures, but now they have confirmed that the mighty volcano was just a giant volcano. Tamu Massif is a rounded dome that measures about 280 by 400 miles, or 450 by 650 kilometers, or more than 100,000 square miles. Its top lies about 6,500 feet, which is about 2,000 meters below the ocean surface. The base goes down to a depth of about 4 miles or 6.4 kilometers.
Tamu Massif makes the largest active volcano on Earth, Mauna Loa in Hawaii, which measures about 2,000 square miles or 5,200 square kilometers, look like a child's toy. Made of basalt, Tamu Massif is the oldest and largest feature of an oceanic plateau called the Shatsky Rise in the northwestern Pacific Ocean. The total area of the rise is equivalent to the landmass of either Japan or California. The name Tamu Massif combines the institution the scientists came from and a French word. Tamu means Texas A&M University, while massif is French for massive and is a scientific term for a large mountain. So the scientists believe that Tamu Massif was created by a single volcano and probably over a short period of time. That actually took a few million years, but on the universe timescale where some events take billions of years, it's quite short. The volcano went extinct or inactive not long after it formed. That was probably in the late Jurassic to early Cretaceous period about 145 million years ago. How did Tamu Massif form? It seems the spot on the seafloor had the right mix of elements, including a boundary of 3 tectonic plates, a thin crust, and a source of hot magma below that was able to bubble up to the surface. The molten rock poured out and then built up a wide, gradual rise as it cooled. However, just how the magma made it to the surface has not been established. Perhaps a blob of the rock got superheated and then rose to the surface due to buoyancy, or cracks in the overlying crust could have opened, allowing molten rock to spill out. And as massive and powerful as volcanic eruptions are, sometimes they go unnoticed, and scientists have to find clues after the fact to piece together what happened. This was the case that made scientists study a floating raft of pumice up to 5 meters thick that covered 400 square kilometers of ocean. Giant hunks of pumice the size of SUVs strewn across kilometers of the sea floor, a thick layer of sticky ash, and 14 lava flows. These are the clues that scientists hope will lead them to solve the mystery of the largest deep ocean volcanic eruption on record. We'll go back to 2012 when the Havre Seamount exploded with a volcanic eruption that was 1.5 times the size of the Mount Helens eruption in the United States. No one noticed anything about these outbursts from the Earth's crust until a few days later. That was when an airline passenger looked out the window as she flew over the Pacific Ocean. At 800 kilometers north of Auckland, she spotted an enormous floating raft of pumice and quickly took a photo which she sent to a geologist. Unknown to this passenger, she had set in motion an international effort to solve the mystery of an underwater volcano. Later, in October of that year, the NIWA research vessel Tangaroa carried out a scan of the Havre volcano using an echo sounder. Creating a map from the data, scientists discovered that the map was quite different from how the seamount had looked when it was discovered in 2002. This actually confirmed other evidence suggesting that Havre was indeed the volcano that had erupted. 3 years later, a group of scientists headed to Havre intending to create a more detailed map of the volcano, taking photos and collecting rock samples. Of course, the evidence of the submarine eruptions these scientists were looking for is hidden beneath hundreds of meters of seawater. This made it very difficult to study, but an invention came to the rescue: underwater robots. The remote-operated vehicle, ROV, Jason, was connected to the research ship with a fiber optic cable, allowing the operators to see what the ROV was looking at as they drove it around. The underwater robot was also able to take photos and collect samples. The automated underwater vehicle AUV Sentry was pre-programmed to follow a set route as it took photos and measured water chemistry. By the end of the expedition, the team had generated a much more detailed digital map of the volcano. This map revealed numerous lava flows, a widespread ash layer, and millions of enormous pumice blocks, up to 9 meters across, scattered over the ocean floor. The robot also collected a number of large pieces of pumice. One of the things scientists tried to discover was the nature of the eruption. Volcanoes could be explosive or effusive. Explosive means, well, the volcano explodes, while effusive means that lava flows steadily form a vent. This is where the scientists found themselves at a crossroads because the ash supports an explosive eruption while the pumice and lava point to an effusive eruption. Speaking of volcanic eruptions, Huayna Putina is the site of the largest volcanic eruption ever recorded in South America. The explosion was so powerful that it sent mud flows down to the Pacific Ocean 75 miles or 120 kilometers away. Scientists even believe this eruption, which happened in 1600, affected the global climate because the summers following the eruption were some of the coldest in 500 years. Ash from the explosion deluged a 20 square mile, 50 square kilometer area to the mountains west, and you can still see the ash today. Although Huayna in Peru is a lofty 16,000 feet, 4,850 meters, it's somewhat sneaky as volcanoes go. It stands along the edge of a deep canyon, and its peak doesn't have the dramatic silhouette often associated with volcanoes. The Huayna volcano damaged two close cities of Arequipa and Moquegua, and it took a century for them to recover. The volcanic eruption of Krakatoa was more recent but no less deadly. It spent months giving warning rumblings before finally erupting on April 26th and 27th. The explosive eruption of this stratovolcano, situated along a volcanic island arc at the subduction zone of the Indo-Australian plate, shot out huge amounts of rock, ash and pumice. The terrifying sound was heard thousands of miles away. The volcanic explosion also created a tsunami whose maximum wave heights reached 140 feet or 40 meters. The tsunami recorded a death toll of about 34,000 people. More than 7,000 miles away, the Arabian Peninsula recorded an increase in the wave heights of tidal gauges. The island that housed Krakatoa was completely destroyed in the eruption. However, new eruptions beginning in December 1927 built the Anak Krakatau, meaning child of Krakatau, cone in the center of the caldera produced by the 1883 eruption. Anak Krakatau randomly comes to life and builds a new island in the shadow of its parent. One of the largest eruptions in the 20th century was the Santa Maria in 1902. The violent explosion in Guatemala came after the volcano had remained silent for roughly 500 years. It created a large crater nearly a mile across on the mountain's southwest side. The symmetrical tree-covered volcano is part of a chain of stratovolcanoes that rises along Guatemala's Pacific coastal plain. It has experienced continuous activity since its last blast, a VEI-3, which occurred in 1922. In 1929, Santa Maria spewed forth a pyroclastic flow which claimed hundreds of lives and may have taken the lives of as many as 5,000 people. Another volcanic eruption that changed the world is the Thera eruption in Greece. Scientists believe that had Thera not erupted 3,500 years ago, the map of the world would have looked different. It is believed to be the single most powerful explosive event ever witnessed. There blew a large hole in the island of Santorini and sent the whole of the ancient Mediterranean on a different course. The eruption also had political effects. It completely destroyed the Minoan culture, which was the most dominant in the region at the time. While historians and archaeologists can't agree on the year Thera exploded, there have been suggestions ranging from 1645 BC to 1500 BC. But what is not in doubt is the evidence from ash deposits found in the ocean floor that Thera erupted with a force that humans have never witnessed. The picture would have been easier to piece together because no first-person account of the event exists, but researchers have been able to bench it against the Krakatoa volcanic eruption. Thera killed more than 40,000 people in just a few hours and generated colossal tsunamis 40 feet tall. It also sent volcanic ash across Asia, causing a drop in global temperatures. It even created strangely colored sunsets for 3 years. People heard the terrifying blast 3,000 miles away. Scientists say Thera's eruption was 4 or 5 times more powerful than Krakatoa. It exploded with the energy of several hundred atomic bombs in a fraction of a second. Meanwhile, scientists have not found human remains and valuables belonging to the Minoan residents of Santorini. This suggests they were able to predict the eruption and evacuate the island on time. Based on the nearby island of Crete, the powerful Minoan civilization declined suddenly soon after Thera's explosion. Tsunamis spawned by the eruption would have swamped its naval fleet and coastal villages first off, according to historians. The drop in temperatures caused by the massive amounts of sulfur dioxide spouted into the atmosphere must have also led to years of cold, wet summers in the region, ruining agricultural harvests. The lethal combination destroyed every notable Minoan stronghold in less than 50 years. This led to a free-for-all in the political vacuum created, leading to the warring city-state system of ancient Greece that would dominate the Mediterranean. The Aegean would turn out to be a fundamental building block for the history of Europe, and the Minoan decline changed its early foundation completely.
So are we at risk of another catastrophic eruption? Yes, in a nutshell. Yellowstone Park is home to a caldera that would scare the socks off everyone on the planet, not just you. If the Yellowstone supervolcano were to erupt, it would bring the entire world to its knees and obliterate all life on Earth. An estimated 2,100,000 years old, the Yellowstone volcano has erupted approximately every 600,000 to 700,000 years since its formation. Since the last eruption was 640,000 years ago, we can't be sure if the supervolcano would explode in the same manner as in the past. This will not be the first civilization to be at the mercy of a supervolcano if Yellowstone's supervolcano decides to erupt. Mount Vesuvius, a supervolcano, was historically recognized for destroying an entire civilization in 79 AD. On a scale of 0 to 8, the eruption received an 8 rating. Archaeologists are still excavating the ashes of Pompeii to find old artifacts and the charred remains of those who perished in the blaze. Although scientists keep an eye on earthquakes, ground deformation, stream flow, and temperature changes in Yellowstone, it's not certain how much notice a supervolcano will provide before erupting. Smaller eruptions from supervolcanoes relieve the pressure on the magma chamber on a periodic basis. More than 80 non-explosive lava-producing eruptions have occurred at Yellowstone in the 640,000 years since Lava Creek, and the next eruption is more likely to be on the size of Pinatubo than a supervolcano. But what if we're not dealt a favorable hand? What would the effects of a Yellowstone supervolcanic eruption be? Most super eruptions happen in locations that are active for millions of years but then become quiet for a long time. So don't put your faith in Yellowstone's seeming peace. Overall, longer dormancy leads to greater growth in most cases. Yellowstone rests on a long-active tectonic zone with a weakened and thinned crust overlying a 2,500 Fahrenheit, 1,370 degrees Celsius magma dome rising from the upper mantle, similar to other supervolcanic locations. This dome has melted and broken through the crust, forming two magma chambers that are around 5 to 7 miles, 8 to 11 kilometers beneath, and both measure more than 30 miles, 48 kilometers broad. These magma chambers are filled with a mixture of magma, semi-solid rock, and dissolved gases such as carbon dioxide and water vapor. Additional magma builds up over hundreds and thousands of years, delivering more heat and pressure and gradually forcing the overlying ground upward. When a consistent supply of hot magma is delivered to the chamber, pressure builds in a cyclical process known as incubation. If it doesn't, some of the material will solidify and sink, releasing the pressure. Because of the massive size of a supervolcano's magma chamber, incubation necessitates a heat delivery rate 2 to 3 orders of magnitude higher than a typical volcano. Fractures form along the dome's periphery as a result of excessive pressure, which allows air to escape the chamber. As the gas-filled magma erupts, pyroclastic flows, fast-moving, thick clouds of gas, ash, and rock boiling out from the eruption at 1,470 degrees Fahrenheit, 800 degrees Celsius, cover tens of thousands of square miles, raining ash and debris. Additional blasts will be sent out on a weekly basis. On a regional scale, ash falls down, polluting the atmosphere and blanketing tens of millions of square miles with inches of crop-killing ash. Anyone within thousands of miles of the explosion risks inhaling microscopic glass needles, shattering pulmonary blood vessels, and drowning in a slurry of ash and lung moisture until it settles. As a result of the ash falling from the sky, polluting the water supply and clogging up vehicle engines, food supply, transportation, communication, and economic crises can develop that can last months or years. Global average temperatures are expected to drop 5 to 9 degrees Fahrenheit, 3 to 5 degrees Celsius within a matter of weeks due to an unexpected buildup of dust and sulfuric acid aerosols over the globe. 3 feet of hazardous volcanic ash would engulf a third of the United States, rendering it uninhabitable for months, if not years, in places like Montana, Idaho, and Wyoming. To put it in perspective, a Yellowstone explosion would be 25,000 times larger than Mount St. Helens. It wouldn't necessarily be the lava flows and ash that killed you. It could be the terrible fallout from the lava flows and ash that destroyed the Midwest or the global cooling that resulted. There are currently no signals that Yellowstone supervolcano is on the verge of erupting. Apart from evacuation, there is only so much we can do once indicators appear. As soon as this event occurs, not only would our way of life change, but the global economy would suffer as well. If Yellowstone does not erupt, another super eruption will occur somewhere on Earth at some point in the future. Don't you think it's about time we get moving on that Mars colony.